Hello, students, and welcome to another screencast with Mr. Swan. What we're talking about today is eclipses, both solar and lunar, why they happen, and other neat fun facts about them. So let's start off with a solar eclipse. A solar eclipse, if you've ever seen one, then you're pretty lucky. Most people usually just see them on TV or in pictures, but this is probably what you're thinking of when you think solar eclipse. The moon has gotten in front of the sun from the vantage point of Earth. And so what I've written here is, as the moon revolves around the Earth, the moon may block some sunlight that should hit the Earth. The moon's shadow will then be projected on Earth. This causes a solar eclipse. You have to be in the shadow to see it from Earth. So usually, this is the viewpoint that we think about. From Earth, looking out, and the moon is right here. This is the disk. And the sun's disk is right around the back, and you can't see it. Another different vantage point, as I said, this unit will have two of them, is from in space looking down. And so this is actually taken from the space station, also showing a solar eclipse, but here it is just from a different viewpoint. The solar eclipse is happening right here. The bottom right hand picture, that little black dot. Why this happens? Different viewpoint. Sun's rays are coming right on in, the moon's blocking them, but that shadow the moon is casting must hit the Earth. If it doesn't hit it, well, then we just see nothing. If it hits it in a location that you are not, well, then you also see nothing. So a lot of things have to align up just right for a solar eclipse. We'll come back to that in just a second, because I know you wanted to see a video of one. And I won't actually play the whole video. I'll have it linked, so we'll talk about it. But if you ever get to go, and they're pretty rare, so if you have one in your area of the world, it's also a little bit of a rarity, but it is totally worth the trip. The last one that happened in America just a couple of years ago, sometimes they call it the Great American Solar Eclipse because it went all the way from West Coast to East Coast. A good majority of America probably saw it. And this is what happens if you ever kind of get to go. You'll see as the moon goes over the disk, it's a slow process, but the moon covers up a good majority of that disk and just slowly covers up more. And so you kind of see like a little bit of the sun left, and then you just see nothing. So during this time, if you're ever there, it will start to get darker outside. It gets darker and darker and darker. During this whole process, it never actually gets totally like pitch black dark, but it just gets darker. It's like the sunset is happening. And so as it continues to go on and on and on, eventually the neat part about the solar eclipse is that as the moon is passing in front of the sun, let's go back right here. Once it gets all the way, once it gets to 100%, it's like a light switch is flicked, and your whole viewpoint of this changes. Like almost in a blink of an eye, it's like you see like a light flash, and then you see something brand new. So this is the camera that's recording this is going through that. They're going to readjust the lens to eventually refine it, but that won't happen for that amount of time. It would be a lot quicker. And jump right to here, and then you can see the solar eclipse that is actually occurring. So if you ever happen to get to see a solar eclipse, one important thing to know about is that you should never look directly at the sun ever in your life. It will hurt your eyes. But right in here at this one time, which it will last about a minute, maybe two, you can look at it. You can look at it without any kind of special glasses or any kind of protective film or anything like that. You can look right at it, you can see it, and people will be like, whoa, that's really, really neat. And it truly is a once-in-a-lifetime kind of view once you get to see it. What becomes the issue is when people look here without any kind of protective glasses on. And what you're doing is you're looking at the sun. If you've ever looked at the sun, which everybody in here probably has at one time or another, it hurts. And it hurts a lot, and you stop doing it. But for the solar eclipse, it is such a neat and rare thing to see. People will continue to look at it. And the amount of light coming in is not enough to really cause a lot of pain, but it is enough to kill the cells that make up your vision. And what will happen is that if they die, they'll die in that pattern. So they'll forever see kind of like this missing part of their vision. And so that happens. That happened during the eclipse a couple of years ago. And some people did it because they didn't know. Other people did it when they try to protect their eyes because they wore a pair of sunglasses. And a pair of sunglasses does not work. I think I read once you needed like 30 to 50 pairs of sunglasses to get that kind of like protection, and nobody's going to wear that amount to go look at the sun. So when they say wear protective glasses, they're talking about Mylar film glasses. And I have some of those. I'll have to show them to you when we get back. or when I get back, and we'll go take a look at the sun in a protective fashion. But that is a mistake that sometimes people make. So it's always good to know about it, so you don't fall into that. The next one, we talked about solar. Let's move on to lunar. A lunar eclipse, a little bit more common than the solar eclipse. When a lunar eclipse is, well, the moon has now moved. So instead of the moon being right here between the sun and the earth, which is also a great time to bring up, when the moon is right here between the sun and the earth, solar eclipse, the phase of that moon has to be a new moon. It must be a new moon because you cannot see the surface of the moon. All the light is on the back half of that moon. A lunar eclipse is now the opposite. So the moon has moved from between the sun and the earth to around the back part. And so a lunar eclipse looks like this. Probably one of the best pictures I've ever seen. That can only ever happen during the moon phase full moon. And what is happening? Because sometimes we think shadow on the earth for solar, it looks really dark, but for shadow on the moon, it doesn't really look dark at all. It just changes color. So here's the reason why. As the moon revolves around the earth may block some sunlight from hitting the moon and have a shadow projected on the moon. This causes a lunar eclipse. From Earth, it appears to be a reddish color because of the refraction and scattering of the sunlight that is going through Earth's atmosphere. So the Earth is way bigger than the moon, and the Earth also has an atmosphere. So when sunlight comes in and it hits that atmosphere, the white light breaks apart, and then colors then break apart, and then it gets scattered, and we see those colors. So during the just a mid-afternoon, the sky looks blue. If you wait till the sun actually angle changes, light is hitting you at a different angle, and it will look more like reddish or orangish before like a sunrise or sunset. So for the moon, light is hitting. Some of it hits that atmosphere right on the edges of the surface, and then so it gets bent back on down, and when it gets bent, it scatters and breaks apart, kind of forming to a degree like a rainbow, except you don't see that rainbow because that light has to hit off something and then shine back to your eyes. So it breaks apart into colors into space, and yet we see none of them until something gets in front of one and then reflects that back to us. So that is the moon. So then the moon actually goes right behind the earth. Sometimes you probably have seen this in your lifetime a whole bunch of times. Sometimes you look at the moon and it looks white. And sometimes you look at the moon, it has maybe a slightly bluish tint to it. And other times you look at the moon, you're like, wow, that looks kind of yellowy. And other times you look at the moon and it looks red. And that is what the best lunar eclipses are. They look like a red, orangish kind of color. So if the moon was, farther back, then this wouldn't happen. If the moon was closer, this wouldn't happen. So it has to be in the most correct position. And that's the neat part about the eclipses, is that they're not common. The solar eclipse, when we look at other celestial objects in our solar system and even, throughout our galaxy, this is not a normal thing to have the moon, which is way smaller than the sun, be at just the right distance that is the same size in the sky as the sun. So that's if we ever found aliens, we would be like a tourist destination. They would come to go see these solar eclipses, and this won't always happen in the future either. The moon is actually moving back a couple, a centimeter or so per year, and then after a while, enough years, it won't make total solar eclipses anymore. It will make eventually these ones called an annular eclipse, where the disk size does not cover up the sun. So this would be called an annular eclipse. If you want to see eclipses sometime in your lifetime, well, here's the map to do so. For the next about 20 years or so, here's all the eclipses that are going to be mapped out in their position. Remember, space is very, very predictable, and the object's movement is very, very predictable. Blue is total. The red is the annular. And the next blue one, luckily for you guys, is in 2024. That is when you'll be 21-ish, I'm assuming. So you'll be in it's probably college-ish, or maybe being close to finishing, and you'll be able to see the next solar eclipse at that point. And the great part about it is it happens really close to New York, not for Burnt Hills. We're going to be about 99. The sun will be at 99% covered from us, or the moon will cover 99% of the sun for Burnt Hills-ish region. So you have to go out west, maybe Buffalo, or some place up further up in New York to actually go see it. So let's continue on this brings up a good point. Why have you seen the moon in lunar eclipses so often, but you don't really see the solar ones as often? And the reason is because of this. The moon's plane of orbit. I've shown you pictures in the notes and on different screencasts. Usually from like a top-down point of view. But if you look at it from the side point of view, sometimes people imagine that it kind of goes right around this plane of orbit that's like 0 degrees, which means it equally matches the Earth. If it was like that, we would have a solar eclipse every month. We'd have a lunar eclipse every month. Every full moon would be a lunar eclipse. Every new moon would be a solar eclipse. It does not work that way. The moon actually has a little bit of a tilt to it. Not much, about 5 degrees. So on occasion, when the Earth is revolving around the sun in such a way that the moon is at maximum tilt, about 5 degrees, that the moon's shadow doesn't hit the Earth for a solar eclipse. And then when it goes back around the other part, the Earth shadow doesn't hit the moon for a lunar one. And this is just kind of what happens. This is why it is so rare. For a total solar eclipse, not only do you need to have it at the correct orientation tilt, but then you need to have it so that moon phase has that the full moon phase actually hits your location, your exact location on the Earth. It is just an incredible rarity. That's why it just hasn't happened in a really long time. After 2024, for solar eclipses, I don't know when the next one is after that. Even for most of America, it's way, way out, maybe in the 2060s. Just a guess. I really do not know. It's really, really far away. So I showed you the total solar eclipse video. I just realized I did not show you the lunar one, so let's do that. We're just super fast. This was a quick video taken by an observatory, and they just had their telescope fixated on the moon, and then they moved the telescope to match, so it looks like the moon's kind of not really moving in the sky, but it actually is. And it kind of works the same way. The shadow starts to kind of cover it. And then just like the solar eclipse, once it gets all the way to the very end, it's like a light switch flicks on, and it just turns a different color. So that's like my opinion, the best part about these things. And it turns a nice red. And then it moves out of position. And then it will start to turn white again. Then as night turns into day, the moon will eventually crash right into the ground. Or they just had orientation on the telescope focused on it. A neat end to that video, one of my favorites. So let's continue on. So we talked about solar eclipses, we talked about lunar eclipses, the rarity of them. You're just not really going to see a solar one so much. A little interactive for you guys to use in a little bit. What I'd like you to do is feel free to go to swanscience.com, go to screencast lessons. This is lesson number 2. The link to this video will be right here. You guys are going to do the Moon Lab. I think one class has already done it, but some of those have not. So what this is, it's really a 2-part lab. I only have enough equipment for maybe about half maybe groups of 2, about half the people to use one and the other half to use the other. So when you're done with it, just trade. So some people will start this lab at part A, and some will start at part B. Either location to begin with is totally fine. Part A, you're going to be using 3 wooden balls. One of them is blue to be the Earth. One of them is yellow to be the sun. The other one is white and black, and that's going to represent the moon. And what you and your partner are going to be doing is just put them in different locations. So kind of like a top-down perspective. You put the moon right here, you have the Earth right here, and you have the sun right off to the side. And you just need to know what moon phase is that. So this is a lot about moon phase practice. If you were to change that, you put the moon like over here. Well, what moon phase is that? If you were to move the sun, so the sun's up towards the top, and then you have the Earth, and then the moon's over here, what phase is that? So you don't have to be perfect at this yet, but this is just a different way to practice and get better at it. Part 2, I don't really have a picture, but what those are is what I call moon lollipops. They are a moon orb, kind of like on a stick. Half of it is painted white, half of it is painted black. And what's going to happen is that one partner is going to hold that and walk around the other partner with it. While walking around, they have to hold the white half facing the windows of the room, the black half facing the hallway side of the room. And then what the person in the middle that they're walking around will see, if they hold it exactly so the white half is always facing the windows, they're going to see moon phases. They're going to see the moon phases slowly changing. So that is the goal. And that's just another moon phase practice. When you're done with that and you're done totally with the lab, go ahead and take out go check out those videos. The solar eclipse one I showed right here, the woman brings up some really great explanations about it. The lunar eclipse one is right here. The eclipse simulation that I showed you is right here. And then I have a couple gizmos for you to work on as well. So go give those a try. Let me know if you have any questions. Feel free to send me an email. And good luck and learn all about the moon. All right, I'll talk to you later. Goodbye.